My name is Esther Munoz, and this is my informative speech. Is mathematics created or discovered? This is a question that has plagued experts for many years, and the answer is not easily agreed on. One of the many factors that contributed to this is that it is important first to understand what do we mean when we say that we are doing mathematics. According to the Stanford Encyclopedia of Philosophy, there are at least three schools of mathematics: intuitionism, formalism, and Platonism. I believe it is extremely useful to think as a formalism when we're tackling the discipline of mathematics. Its rigorous approach greatly minimizes the margin of error in its manipulation of the symbols, while simultaneously allowing for the creation of new kinds of numbers to tackle problems with seemingly no solution. This process in itself helps to promote human creativity and broaden the horizon of human achievement. So, what is formalism? Formalism helps mathematics to be the manipulation of meaningless symbols. Now, if symbols can be assigned meaning, then the implication is that these symbols are subject to human thought. Thus, new kinds of symbols and new kinds of meaning can be created. Historically, an example of the creation of new numbers to tackle problems with seemingly no solution is the creation of calculus. Now, with calculus, what we are looking to achieve is to find this instantaneous rate of change of a function, or like in other words, to find the slope of a singular point in time or a singular point in a graph in a real number. Let's denote it C. Now, with the current system of numbers that was available at the time, this required the use of a number that is said to be negligible. Now, instead of the real numbers, the pre-established mathematical structure available at the time, the only negligible number available is number 0. However, James Henley, in his book Infinitesimal Calculus, talks about how this will give out an undefined slope, thus completely defeating the purpose of using a negligible number. Now, what kind of number will be needed? Well, mathematicians are faced with the idea that they need a number to be infinitely close to 0, but not 0. Now, according to LibreText Math, this number will be defined to be as greater than 0, but smaller than any other real number. Thus, the creation of the infinitesimal came to be. Now, what happened here? What happened here was that mathematicians expanded a standard model, the line of the real numbers, into a non-standard one to expand it into the hyperreal line. A hyperreal line contains numbers that are both standard and non-standard. The non-standard part of a hyperreal number is the infinitesimal, and the standard part is the real numbers. In other words, the pre-existing system of numbers available. Now, why is it important? Why is this relevant? Well, contrastingly to other schools of mathematics, said the Platonists, Platonism tends to have a much more intuitive approach to the study of mathematics. It believes that the symbols that we use when we say that we're doing mathematics, like number symbols, are merely placeholders for real objects whose existence is independent of human thought. How is this dangerous? Well, if we are faced with a problem with seemingly no solution, then that is a dead end. There is nothing that can do if no new number can be discovered. And if it does not exist, then the problem has no solution. However, using formalism, if there is seemingly no solution, mathematicians are able, through rigorous proofs, create their own solution, thus broadening the horizons of human achievement. So why is a rigorous approach to mathematics extremely useful? Well, being rigorous and a rigorous interpretation of the symbols allows for no confusion that can be found with a much more intuitive approach, such as like a Platonist one. When the interpretation of symbols is rigorous, then the margin of error is greatly decreased. Contrastingly, with Platonism, the margin of error is directly correlated to the assumption that our interpretation of the symbols is, in the first place, a correct one. With formalism, there is no need for this assumption whatsoever, so we can be sure that our interpretation of the symbols is correct as long as we are in a consistent agreement in our definition of them. In this way, it is that formalism is extremely useful. Its rigorous approach to mathematics greatly decreases its margin of error, and it allows for the creation of new kinds of numbers to tackle problems with seemingly no solution. Thus, it serves as a great incentive for human creativity and it broadens the horizons of human achievement. Now, if numbers can be created, then their discovery becomes unlimited. Thank you.